Hello, welcome back to Python Challenge for All. Okay, so now we are close to the end of our journey about eight puzzles and 15 puzzles. Okay, let's see where we were last time. So last time we tried iterative deepening depth first search, which was somewhat improved version of depth first search, but it was not good enough. Let's see the last code. So we tried 4 by 4, 15 puzzles with a fixed number of, say, 8, and let's run it. If we run it, S, it's running, but million, 2 million. See that the D limit is still 30, which is not actually good enough. So we want to have appropriate DLIM to reach the solution much faster than this. So today's idea is a new one called iterative deepening A star, which is a kind of hybrid of IDS, iterative deepening search, and A star. Okay, so here use an F cost limit, which is, yeah, F value, you remember that, which is a G value, which is path length from start to goal, the actual cost from start to the current state n, and also the h of n, which is an estimated cost from the current cost n to goal. And estimated cost heuristics, we found that h2 value, which is a total Manhattan distance of all the panels in the current state, is a good one. So let's try this IDA A star. Okay, good point is that it has advantage of low memory usage like IDS and good cost estimates like A star. Okay, let's try that. So it's kind of, we can start from recursive IDS, and then instead of DFS, we implement a little improved version, IDA star, which in addition to the first parameter path, which also have dlim as second parameter. Okay, let's implement that. So here, let's change this part later. So instead, okay, let's first save as 989. Okay, so E89, IDA star. Okay, IDA star. Very good. So here, instead of DFS, we implement IDA star, and as a second element, we give dlim. Okay, so basically this part is the same, but here stat is, and then, yeah, we don't check this part. We don't need it. Okay, and first we check the current state is goal. If it's goal, it's fine. Else, okay, we calculate the F value of the current state. So eval stat of path. Okay, let's see. Eval stat is still in here, which is basically the no, actually, I see. Okay, eval stat should have path instead of stat. Okay, and eval stat should have gval, which is length of path minus 1, maybe, because what we want is the path cost from the start state to the current state. And then stat is the last element of path, as you know. Okay? And then we calculate hval from stat and return gval plus hval as eval state. Okay, this is fval, you know. Okay, so here fval is returned. Eval stat will return the current fval, f value of the current state, okay? And use it as a delim. So next thing we should do about here is that okay, if fval is greater than the current delim, then return fval. This is interesting. In former implementations, the return value of IDA star DFS was either path list of states, which is a path in the case of success, or none. But now we have the third kind, which is integer, which is a calculated fval. Okay, and then what we need to do is we kind of have delim minimum, okay, which is, okay, here we define max val, okay, and then we will define max val as, for example, equal 10 to the power of 10, okay, 10th power of 10, which is very large, almost infinity. So we use this as the initial delim value, and then we calculate we make a list of new status, and then for each new status, if that new stat is in path, just continue, forget about it. Else, we calculate new path as path plus new stat, and then call IDA star with new path and delim. This one, okay, delim. And then check the return value. In this case, as I said, there are three ways. So is instance, if return value is a list, okay, if is instance as list, this means if the return value is a list, then it means we found the path to the goal. So return as, that's fine. Okay. Else, if returned value is delim smaller than delim mim, then we change delim mim, delim equals return value. Okay. And then, okay, sorry, read. And else, if we found string, this search is unsuccessful, return delim min, the new value. Okay, so this is a kind of confusing, so please check it very closely. Okay, okay, then the calling part. In solver, yeah, it's almost the same, but before calling path, we calculate delim as eval stat of the current path, okay? And then, instead of for loop, we use infinite loop. while true. And instead of calling DFS, we call ID A star. And as a second argument, we give dlim. And then again, this part should be changed as if is instance, ans is a list. Okay, then it's a success. So return it as usual, as last time. But else, if ret is same as max value, then this is successful, unsuccessful. No. And then else, otherwise, change dlim equals ret value. And then repeat it. Okay, actually, this is all. I hope this works. Okay, let's give fixend to 8 and run this. I hope, yeah, please check the code carefully. I changed here, I changed here, and I changed here. Okay, that's all. Okay, let's check. Before that, I forgot. Let's see about, Okay, move panel or show step. I put only invenam, which is not great. So let's do this way. Let's change this row diff should be 0 if nn is e odd, else. Okay, so for 8 puzzles, it should be always 0. For 15 puzzles, it should be this value. Okay? So this should kind of change. We don't need this. This is good enough. And here too, this is good enough. It's okay to be here. But for show steps too, we add plus. Here, plus row diff. Okay, so let's see this. This means that every time we move, okay, so here we tried 15 puzzles with the first upper 8 panels fixed. And this is okay. So let's S. Max value is not defined. Max mal. Maybe I misspelled it. Max val. Okay, sorry. S. $52. Sorry. Something is wrong. It should be ans. This should be ans too. Why did it write it? Okay. Is this all? Yeah, I guess so. I misspelled, misused. Here too. This should be ans, not ret. Sorry. Okay, let's run it. Okay, S. Okay, could solve in 24 steps. Good enough. And as you can see, this value remains always even, leading to, yeah, step. Okay, good. So maybe this was too easy. So let's change this fixend to 4 and see what happens. This is more challenging because we have all these panels S. Okay, solved 41 steps after, say, 100, 200,000 steps. Good. So maybe we can find good solution. Seems it's optimal. Oh, marvelous. N, S. Good. So it seems always we can find good results. Okay, this one, 2. Good. How about fix n to 3, which is more challenging? Okay, S. Oh, it's taking time. Maybe you can check yourself, but uh, okay, 1 million. Depth is 44, 2 million, and 46. So as you can see, we can increase the D limit very fast compared to IDS in the previous case. So let's go back to the slide while it's running. So if goal is found, return path as a list, and otherwise set new limit at smallest n that exceeded previous limit. This is the code. Please check the code. And evaluation. IDA star finds an optimal solution very fast in 15 puzzles as well. This is my message today. And for some of the 15 puzzles, of course, it's challenging, but it can give good results very fast. Please check yourself and see how wisely it solves most of the very challenging 8 puzzles. Okay? And in the next session, I will summarize the findings. But anyway, let's see. Oh, 11 million. It's still working. Um, Hope we can find it eventually. Not so um, so many hours. Maybe several more minutes. Okay. So I hope you will try it yourself, and hope you will come back. Bye bye.